Good afternoon, everybody. I am your co-host, Joseph Moragrega.
Hi guys, and I'm Carlos Ramirez. So we now have a very special guest. First of all, we have Prem Kumar. He's the Senior Vice President and Head of Technology and Solutions Office Digital Solution at Hitachi Vantara. We also have Neil Lewis. Neil Lewis is the Cloud and as a Service Sales Leader at Hitachi. And we have Krishna. Krishna is the Cloud and Infrastructure Services Business Operation and Technology Leader. Hi guys, are you around? How are you?
Hi, nice to meet you. Thank you.
Nice to meet you, Carlo.
Hi guys.
Thank you guys for being here. We're very grateful and happy to count with you guys in here and show us some of the goodies that you have. The topic of the presentation that you guys are going to be showing us is optimizing and securing hybrid cloud environments. Very interesting and very relevant topic to today, right? So without further ado, guys, the floor is yours.
Thank you very much. And good afternoon, everyone, and welcome to this session, which essentially is on techniques and our learnings to really help optimize and secure your hybrid cloud environments. So before we get started, my name is Neil Lewis, and as Carlos was saying, I lead our cloud and as a service business here at Hitachi Vantara. And I'm joined by two of my colleagues. So Prem, who leads our technology and solutions office, and finally KP, who leads our cloud engineering practice. So enterprises are leveraging cloud for their business capabilities and not just the IT capabilities that sit underneath that. So really to deliver services and outcomes via cloud for our customers and employees around different locations, enterprises really need to leverage more than one cloud platform, leading to having what we term floating data centers, which we'll explore in some more detail shortly. So firstly, let's look at the cloud operating models which enterprises are using. And where we are today has been as a result of lots of evolution over the past number of years. So we should first of all start with a terminology alignment, because it's important to ensure that we're essentially talking the same language. So you often hear hybrid, multi, and even now distributed cloud as being the ideal operating model. But what does that actually mean in practice? So we'll start with a multi-cloud. And this is essentially the concept of using multiple public cloud services rather than focus on a single vendor. And this is now mainstream across most enterprise customers that we work with. The idea that a customer would standardize on a single vendor to get all of their cloud needs just isn't practical any longer, as most cloud services have become much more targeted towards a market or a specific purpose. For example, leveraging Workday for HR or leveraging Salesforce for CRM. It's essentially a best of breed approach to select the most appropriate cloud service for your need. So as customers embrace the automation and self-service that's really inherent in all of these public cloud offerings, that also becomes the expectation for on-prem IT. And this is what drives the adoption of private cloud services on-prem inside a customer's data center. So using one or more of these public cloud services on a best of breed basis alongside a private cloud or a number of private clouds is considered a hybrid cloud model. And this is now the preferred model of cloud adoption across most enterprises today. So using private cloud services on-prem alongside multiple public cloud services from a mix of best of breed vendors. And lastly, as customers really move beyond the consumption of simple first generation IaaS or infrastructure as a service type offerings from the public cloud vendors, transforming applications and the application and digital transformation really becomes critical to helping leverage and take advantage of those modern cloud services, cloud native services. So application transformation is really the decoupling of complex application functionality and the data that goes with it into a mix of many microservices, which are subsets of capability, which can then be reused across applications, making integration and development of new capabilities much, much simpler going forward. So as all of those application microservices get distributed across an ecosystem of some private, some public cloud services across many different vendors, but managed by a common control plane, this is essentially considered a distributed cloud model. So previously we saw organizations making a choice of cloud by selecting from one or more of the top cloud vendors. So you'd make a selection of a cloud vendor or a number of cloud vendors, and that would become the organization's cloud choice. But with distributed cloud, we see now that an organization would adopt cloud services which are unique to their individual needs, and a mix of cloud services which are fit for their specific requirement across public and private cloud, which are then abstracted and governed by that common control plane. And that could contain a mix of infrastructure as a service, IaaS services, PaaS, SaaS, and even completely serverless architectures. So this is really no longer a choice of which cloud to go for, but the complex choice and selection of the different ingredients really makes the cloud choices become your cloud. So organizations are leveraging these services on a best of breed basis. And as I was saying, selecting the most appropriate service from the best vendor to fulfill that requirement at that point in time. But those services may eventually transcend the capabilities of one vendor and therefore would coexist across multiple services in the future. And as the barriers are broken down and service and data ingress and egress into these cloud services becomes much simpler to avoid, the traps of vendor lock-in, these services will start to move between providers depending on factors which could change regularly, such as performance, location, cost, and even scalability. And this would lead to the concept of having a floating logical data center, which is made up of abstracted physical services across this distributed ecosystem. So ultimately, adopting these models is far from straightforward. There are a number of challenges that would need to be overcome and a number of choices that would obviously need to be made in selecting vendors and selecting services and abstracting them and bringing them together in that common control plane. So a number of choices are available and a number of challenges are there to be overcome. So today, we're really going to focus on 4 critical success factors, which are key to organizations being successful in this space. And they're essentially establishing solid visibility and control. Secondly, how to cope with security and data governance across a distributed cloud ecosystem. How to manage cost optimization with the various challenges that OpEx type accounting and consuming on a pay-per-use basis brings. And then finally, how to bring about resilience and engineer resilience into your architectures to tame the complexities and ultimately drive value from cloud services to deliver the business outcomes. So we're going to start with the control element first and its real criticality to success. So Prem, can you give us some insight into how this works?
Sure. Thank you, Neil, and good morning, good afternoon, everybody. I'll spend some time talking about the control plane. And I think Neil summarized really well the kind of cloud and how your future is going to look like, right? So cloud is becoming really personal to organizations. They will define it the way they think it's going to drive their business. So essentially, we're getting to a point where it's your outcomes on your definition of the cloud. Now, with that said, the idea is more and more now, hey, when I get this distributed cloud, when I start looking at my data center in a more logical floating data center manner, how do I start controlling it? So the race today is to the control plane, and we can see that all over the place, right? With Google Anthos, with Arc doubling down, with Outpost, and a lot of these hyperscalers also coming into your private environments and still want the ability to control multiple clouds. For example, Azure Arc today has the ability or is building ability to control your Google Cloud workloads. So the idea is the common control plane that starts to abstract and manage everything from converged and hyper-converged infrastructure to your automation and analytics environments or SaaS consumption, to your core data center, the private cloud that you have, your containers, your virtual machines that are running all across the globe, all up to your applications itself. So that's essentially where the focus should be. And that is essentially where we should start thinking about how do we build the control plane. Net in the future, the window into your hardware, into your data center, into your cloud is going to be a software that's called the control plane. We'll go to the next slide, please. Now, how do you start thinking about building this abstraction? Now, there are pockets of work. This is happening across multiple organizations, but we've tried to put all of this together in context, right? Essentially, as you evolve your cloud, what's needed is for your business teams, your product teams, and your engineering teams to leverage an abstraction layer through which they can interact with your cloud, be it provisioning, be it build, be it deploy, and be it run services. To do that, essentially, you need to have a backplane that's agnostic. And we've talked about some of those technologies that are available today that helps you make a cloud agnostic backplane that's not stitched to a particular cloud or a particular vendor. And then you start to think about the notion of a cloud service broker, which essentially helps self-servicing a lot of deployment work that your end customers, like your product teams and businesses and engineering teams, would need. Create catalogs and kits that can allow provisioning of the best breed of services. So to the point that Neil spoke earlier, if I want storage, I could get it from a different cloud as opposed to compute from a different cloud. And I'm talking a bit in future. But as a developer, I don't have to go and understand where it comes from, which cloud it comes from. So essentially, I will be provided with a catalog or a kit through my service broker that as a developer, I'll leverage, and it will provision the right environment for me from your cloud. So that's essentially how we're thinking about a service broker evolution as we move forward. Now, you have to build in lifecycle management, you have to build in policy management, you've got to get a bunch of blueprints built in, all of that integrated through an operations layer that's got enough telemetry and AI ops. So management doesn't become all manual, and a level of automated operations is possible. So that's kind of how we think about the abstraction layer that will help you with a common governance, that will also help you with a consistent and a highly secure abstraction for your backend services and your cloud getting exposed to all of your consumers. We'll go to the next slide, Neil, please. Now, to do this, right, it is not needed for us to start building this from scratch, right? Loads and loads of technologies are getting available, and there is no need for us to get vendor lock-in, no need for us to run behind one specific technology, and no need for us to think it's going to be a humongous task to build this. There are a bunch of technologies that can be assembled together. So essentially, it's about being flexible, leveraging the whole thought process of when we talk about applications and microservices and keeping it small. Can we look at it from that angle? Rather than building a monolithic control plane, can we start leveraging existing technologies to build a highly flexible control plane that can then actually give you the power to plug and play newer technologies that are going to come on board, right? They're going to, every day when I wake up, I at least learn about 2-3 products in the market that are better than what I had yesterday. So essentially for us, the control plane to be able to plug and play newer technologies becomes important. So what we have shown here is a view around what's available, right? From risk networks, Cloud India, that understands and helps you with an infrastructure view around how can I accelerate migration, what could be my endpoint, to really accelerating the migration and automating it through your Ansible, Chefs, and Puppets of the world, to really testing and making sure your landing zones are great, your application is running well, it is secure, to managing it through your AI ops engine such as Datadog or a Stackdriver, right? Below that, you can start to leverage a single dashboard, you can start to leverage common pipelines, you can start to leverage consistent security across your environment. So that's essentially how you will start thinking about building the abstraction that was shown in the previous slide. With that, we'll go to the next slide. So next slide, please, Neil. Yeah, from a control plane standpoint, I think we've looked at what that abstraction means, what are the products that can help us build. The other very important aspect that's not necessarily functional in nature, that's to some extent overlooked in the industry, is resiliency. And when it comes to distributed applications, specifically the microservices architecture, where you'll have a lot of small atomic units running all around the place, trying to make up your business transaction, it is important for us to engineer a level of resilience within these services. So modern architectures, as we start thinking about and moving towards even serverless and event-driven, which is going to get more complicated, right? If not simple. They're all going to be highly distributed, highly complex, They'll, of course, give you the ability from a time to market standpoint, from an independent releases standpoint, from a significant support in terms of managing the code. However, when it comes to an end-to-end business transaction, it's going to get a lot more complex. Always on businesses, right? If you don't want failures, it's not just enough for us to rely on a third-party infrastructure-based resilience. So if you take decades ago, you've got all of this built into mainframes that had enough resilience to support your application workloads, so your application did do anything. Fast forward into 3-tier architectures and N-tier architectures, you started focusing on load balancers and multiple redundancies to support lesser single point of failures and availability improvement. Now, fast forward to today and tomorrow, it's going to be very, very difficult for us to think about redundancy from a 2 or 3 layer perspective. You're going to really need to think about redundancy from an always on standpoint, which means when a service goes down, almost instantaneously, the upstream and downstream services should be able to talk to another service that will continue to render the business. And as we move forward, failures are inevitable, right? With so much distribution, you have to get into this notion of embracing the failure and preparing for it, as opposed to reacting to it constantly. To do that, it's essential for us to understand the failure points in our architectures, in our services, and then start leveraging fault tolerance design patterns. Again, a lot of that are in the market, and we'll talk to that in a bit. And start to leverage that within your applications. So your applications automatically are engineered for fault awareness, which is when I run in an ecosystem, I can understand what's happening around me. And if there is a failure, I as a service can be aware of the failure around me. I will build in fault tolerance. So I continue to operate in the light of the failure, and I can automatically recover in case I fail. So these become extremely important. This is what builds a resilient service. And in a distributed ecosystem, this is important for you to deliver an always on business for your customers. Next slide, please. To do that and to create a service that never fails, and obviously you cannot create a service that never fails, but at least the transaction that never fails, that's stitching across services. We advocate you start with what we believe many manufacturing industries and many other industries have already tried and tested, which is failure modes and effects analysis. This is largely practiced in manufacturing area, very little within the IT ecosystem, but we think it's time for us to start thinking about it so that you start to then understand all the failure points in your application and start to build strategies around tolerance and remediation for those failures that today are supported through some of the products and technologies, right? So there are thousands of design patterns, at least circuit breakers, bulkheads, load sharing, which are very common that are used, that are now being abstracted and provided to developers through frameworks like Resilience 4J, or through products such as the service meshes that you can integrate within your ecosystem that automatically manage some of these resilience patterns. Ultimately, all of this, right, managed through observability or viewed through a 360-degree observability. That becomes extremely important because if you don't see it, it's hard for you to detect and recover from it. So it's essential for us to build observability. And again, that's an area that's developing. There are products that are supporting it, but we also advocate a lot of impetus around open tracing and distributed tracing that could be integrated into your applications. So they provide a level of feedback on what's happening in the ecosystem for your observability products that can then react to it and help prevent failures as opposed to react. Chaos experiments, all of this underpinned by chaos experiments, started some time back with Netflix. They made it big around game day scenarios, around injecting failures within your production ecosystem itself to understand and make sure future releases are hardened. And if you face a problem once, you don't face it again. With that, I'll move on to the next section. So this is around resilience and control. The other two aspects that are extremely important are security and cost control. So I'll hand it back to Neil to talk to us a little bit about security and cost control in the cloud, Neil.
Thank you very much, Prem. Some fascinating insights there. So as Prem was saying, he's covered the importance of a control plane, being able to abstract services out and govern in a single place. He's talked about the importance to achieve resiliency through achieving resiliency within services rather than depending upon infrastructure as we have historically done. The other two important pillars to really be successful in a distributed or a hybrid IT ecosystem is security and cost control. So firstly, turning to security. From a security standpoint, enterprise IT has really for many years adopted the time-proven approach of secure the perimeter, keep the bad guys out the data center, and then trust everything that goes on within. And I think that was feasible for as long as everything remained in the one place. So when all of your data and all of your application services resided within one network protected by a set of firewalls that you could protect the perimeter, that solution would work. But I think as cloud use has really evolved into the distributed models that we talked about earlier, the floating data center concept of services moving around and not being physically located in the same place, it's just not possible to extend that trust everything domain across all these new locations. So really a new approach is needed to security within the enterprise when working in a distributed cloud type environment. And this security model is zero trust, which by default, nothing and no one is trusted within the enterprise landscape. And that really introduces new overheads to understanding the intricacies of how applications and application components communicate with each other and redeveloping legacy applications to work in this new reality. Not relying on services being co-located within the same code stream or running within the same instance. So the security challenges are far and wide in terms of adopting a new zero trust type model. So from a data perspective, it's long been known that data and applications really go hand in hand. This distributed cloud approach requires a new way of working with data, understanding that concept. So it's simply not possible to maintain a centralized repository or a centralized system for all of your data in the way that you would have managed a mainframe or OLTP type system. So because application and data go hand in hand, it really requires a more federated approach to ensure that data is close to the application microservice to manage things like latency and enable data analytics to be performed at the edge as well as the core. But again, this requires a deep understanding of how the application works and how that application or the application microservice would coexist and would operate with its underlying data set in a distributed type model. And finally, a key consideration for many highly regulated customers, so customers we have in healthcare or in financial services and insurance, is really data sovereignty and chain of custody integrity. So when consuming a cloud service, it's not always obvious where that service is running or where your data will end up residing. And that might be great for a tech startup, but for a highly regulated financial services industry operating in many different countries, all with different sets of regulation, it's highly important to understand the data sovereignty implications of migrating microservices or elements of the architecture across this distributed cloud ecosystem. And this is really where metadata can play a key role in ensuring that data and services are properly categorized and managed to ensure that both security and those data sovereignty and data location requirements are maintained in any new federated model. So finally, turning to cost as the final component. I guess an unlimited budget to spend on IT is just not a reality, or it's certainly not a reality in organizations that we come across. So cost is a big deterrent, I guess, for many enterprises that are going on a cloud transformation journey. They need to be confident as to how they can manage this cost exposure going forward. So in some recent surveys, enterprise report that only around 70% of cloud spend is effective. The rest is essentially wastage in the form of underutilized or underperforming or even misaligned or misconfigured services. So what's really required to tackle this challenge is really establishing principles and driving automation to bring about real financial accountability to that variable spend model which cloud brings, and enabling those distributed teams, empowering those teams with the decision-making ability to make trade-offs between speed, cost, and quality of services. And the cloud cost governance is really an important function within an enterprise that will set these challenges or achieve these objectives in future. So they're really going to be there to set policies and have the visibility to act on that guidance in order to really optimize and standardize to make the best out of the capacity and the budget available. So the key facets for cloud cost governance are really metering, chargeback, and other economic considerations, so that the cloud spending in the organization is driven by desired outcomes rather than driven by standard configurations. So automating cloud spend analysis and brokering into that control plane and then adjusting those cloud services for best value, it's really possible then to keep up with the evolution of cloud services without really breaking the bank or blowing the budget as a result. So I think we've covered the criticality of the control plane that Prem talked about. We've covered the evolution of resilience, moving from being an infrastructure dependency up into something which is considered as part of the application service. We've talked about security and data governance and the impact of global regulation on some of the choices that we make. And finally, we've talked about cost control. I think we see these four things as really being the successful ingredients, as it were, of being successful in a cloud transformation journey. So now let's look at what preset recipes are available using the learnings from these ingredients to ensure that you really arrive at an operating model fit for success. So KP, I'll hand over to you.
Thanks, Neil, and thanks for you and Prem to summarize the critical success factors very well. Now we have kind of been interacting with a lot of customers, trying to help them to make sure that these critical success factors come to life, and they're able to kind of like drive a continuous journey of transformation within their enterprise by leveraging cloud. So the simple recipe that we have put forth and what we have been able to achieve, the value and the outcomes customers are looking to drive in their cloud transformation journey is through what we call as a 4E framework. It starts with clearly understanding the roadmap or the target or the journey as to where we want to be, right? So with the destination in mind and a lot of change, a lot of constant evolution of technology happening, how do we still have the right kind of destination in mind is the critical aspect of the envision phase. So looking at demonstrating the target in mind, that's the key outcome from the envision phase that we typically look to drive for our customers. And once we have kind of set the target in place, I think there are a lot of technology choices, a lot of trade-offs to be done. And how do we help customers to kind of like do the right bake-off, make the right decisions, the right choices between technology, people, and even their processes as well to be able to drive value in the cloud journey as well. And this is where we are helping a lot of customers, and a lot of them are also looking at getting a sandbox environment, working with their hyperscalers, implementing their guardrails so that they can still try, experiment everything in a production-like environment and make those choices and then make sure that they're committing to how their journey needs to look like. And once they have evaluated their choices and made their decisions, it's about kind of like going full steam and working wholeheartedly towards the transformation journey, which is what we call as the execution phase or executed scale as well. And I think this is where a lot of the distributed teams or distributed pod model gets into play as well. They work on different kind of objectives and projects and outcomes. And also this is where a critical phase of driving things through automation comes into play as well. So this is the three-stepped approach that we typically embark for our customers when it comes to transformation journey. While change is the only thing that is remaining constant in whatever we do, and along with technology as well, the evolution phase or the kind of keeping a tab on how things are evolving and how our strategy and how our overall roadmap should look like is the aspect of the evolution phase or the evolve phase as well. So these are the simple tried and tested recipes that we have kind of leveraged for helping customers. And moving on to next slide. The operating model that we recommend implementing to our customers, which brings all of these recipe to success or to life as well, is consisting of about 5 critical components. The first component is basically a smart catalog, a layer that enables business to be able to get the right set of services from cloud, and also making sure that there is a dynamic decision framework built in to be able to get the services consumed from a best of breed standpoint. And once that catalog is available and exposed as part of the operating model, it's about making sure that the second layer of brokerage happens, which is to kind of source those services from the different cloud services. And the control plane, which Prem talked about, is a very critical component which enables the smart brokerage of services. And once we have the services kind of like sourced and being brokered, it's about making sure that we have full 360-degree observability to bring in resilience, to bring in the right kind of visibility into operations, and to be able to drive the right insights so that we're able to use data and make everything from a data-driven perspective, even from an operations standpoint. So that's where the AIOps comes into picture, to be able to make sure that every single task is automated and every single process is kind of orchestrated. And again, leveraging data and harnessing the power of data to be able to drive where we should be spending our time and how operations needs to gear towards the business outcomes as well. All of this, again, needs to be managed by a tightly governed plane, which is what we call as the governance and control plane. And this brings in security, regulations aspects into play as well, and also making sure that the services are adding value to business. So this is our, again, tried and tested operating model that we have leveraged to make sure that the critical success factors, the kind of the overall recipe that we have put forth to be able to drive the transformation, all of that comes to life, and it constantly evolves as well. Now, moving on to next slide. We have kind of seen different enterprises having to go through various projects of this nature, various transformation journeys. But the question again comes in like, how do we get the right kind of talent? How do we get the right kind of capacity to be able to deliver all of these transformation projects? And this is where the maturity as we go along in terms of embarking this journey comes into play. So a lot of customers typically look at how they are driving their automation, how they're able to kind of like orchestrate, how they're able to bring the lessons learned from the first project and not kind of like go through the same challenges in their 10th or their 100th project. So this is where making sure that the capability is built within the organization, and it's not just a linear increase in terms of capacity for every single project or every single transformation that they have to go through. And this is again kind of a model that we typically propose as to it's not just a linear increase in terms of capacity or the resources to be able to drive these projects. It's more about getting the mindset of the capability that's required to be able to embark on the journey, and making sure automation and orchestration plays a key part for us to be able to drive more velocity and more kind of strategic projects within the transformation journey that happens. So that's basically what we see as the kind of model, again, tried, tested for a lot of our customers to be able to drive these projects with the right velocity and to provide the right business outcomes. So to summarize it all, I would say that the critical success factors for us to be able to really drive optimized and secured private cloud or public cloud or multi-cloud, anything for that matter, is to make sure that we have full visibility, full kind of control, secure and optimized from a cost standpoint, along with resiliency. All of these are kind of critical success factors baked in for us to be able to drive the full potential of cloud. And the way to achieve that is through the recipes that we talked about, the 4E framework, and they come into life through the operating model that I described as well. So that's basically what is from our experience as to how we are helping customers and how different customers are going through this journey and getting the value out of their cloud.
Thank you, KP. Thanks, Prem. Does anyone have any questions just to wrap up?
Hi, guys. Thank you so much for, well, first of all, congratulations. Thank you very much for sharing your experience and the knowledge. It was very inspiring, and I really enjoyed about all the things that you shared with us about the cloud models, how those works, and the way to have that an optimized cloud services and secure, So it was great and a pleasure, guys.
Yeah, I think that you guys, thank you, Hitachi team. I think that you guys did a great job at summarizing the complexity of our IT today, right, on our world. I mean, we live with this every day, right? And you guys provided a glimpse on how the collective group, right, the organization, kind of start taking the steps towards tackling this huge complexity that we have at hand. Thank you guys for the glimpse. Let me remind the audience, there are more sessions coming up, right? We're still on a road. So in a few minutes, we're gonna be chatting about how AWS is reinventing the cloud. So stay tuned. Thank you, guys.
Thank you.